Right now, Titan could kill you in seconds. In the next few minutes, you'll see exactly why Saturn's famous moon is far more terrifying than it looks, and why some scientists quietly wonder if we should really go there. And the part that will stay with you is how welcoming Titan seems, right up until it isn't. Picture this. You're standing on a beach, but the ocean isn't water. It's liquid methane and ethane. Cold enough to shatter steel. Thick orange haze above you, Saturn looming in the sky. It looks like a dream. It's actually a trap. Titan is the second largest moon in the solar system, bigger than the planet Mercury. It has rivers, lakes, rain, clouds, even sand dunes. On the surface, it feels strangely Earth-like. But every one of those Earth-like features hides a lethal twist. So what makes Titan so uniquely dangerous that some people argue we shouldn't even set foot there? Start with the air. Titan is one of the only moons with a real atmosphere, thicker than Earth's. You'd think that's comforting. It's not. That haze is mostly nitrogen with a few percent methane. No oxygen. No mercy. Breathing there without a suit isn't just suffocation. It's chemical suffocation in air so cold it might as well be solid. At Titan's surface, the temperature is about -179 degrees Celsius, or -290 Fahrenheit. That's colder than dry ice. If you took your glove off for a few seconds, the moisture in your skin would freeze, your tissues becoming brittle like glass. You wouldn't even feel the cold for long. Your nerves would just stop. But the atmosphere hides something even more unsettling. High in Titan's skies, ultraviolet light from the sun and charged particles from Saturn constantly slam into methane. They break it apart, rebuilding it into complex organic molecules. Long chains of carbon and hydrogen, and even more complicated stuff. These molecules drift down, forming a kind of orange smog. Looks beautiful. But it means Titan's entire surface is dusted with chemicals that could be precursors to life. Not life as we know it. Something stranger. Do we really want to walk into a planetary-scale chemistry lab we barely understand? Now imagine you're aboard a lander, descending. You push through clouds of organic haze. The parachute deploys into air that's 4 times thicker than on Earth. That sounds safe, gentle, slow, controlled. But a thick atmosphere also means winds, turbulence, and storms. Except Titan's storms aren't rainstorms like ours. They're methane storms. Hydrocarbon thunderstorms. Lightning may crack through that orange sky, possibly triggering more complex chemistry, maybe even explosive reactions in pockets rich in methane gas. A single strike near a lander could be catastrophic. How do you safely work in an environment where the air itself is fuel? Then there are the lakes. Ligeia Mare. Kraken Mare. These are vast seas of liquid hydrocarbons, some hundreds of meters deep, the size of entire countries. They're so cold that if your spacecraft splashed down and sprung a leak, its metal could literally turn brittle under the thermal shock. And unlike water, methane is less dense, less buoyant. Design a boat wrong, and it sinks fast. No rescue. No second chances. But the real terror might be hidden under the ice. Beneath Titan's frozen crust, scientists think there's a global ocean of water mixed with ammonia. An entire world ocean, locked away in darkness. If that ocean occasionally erupts through the crust, it could create cryovolcanoes, volcanoes that erupt water and slushy ice instead of lava. To a human base sitting on Titan's surface, that's a nightmare. Imagine building a habitat on terrain that might one day crack open and spew freezing brine from a buried sea. We don't even fully know how often Titan's crust shifts. Are we stepping onto solid ground, or a thin lid over a restless ocean? And hanging over everything is this question. What if Titan already has something alive? Not oxygen-breathing, water-based life like us. Something adapted to liquid methane at -179 degrees. Some researchers have pointed out oddities in Titan's atmosphere. Less hydrogen near the surface than expected, a missing molecule called acetylene. Nothing is confirmed. But if weird methane-based microbes did exist there, they'd be utterly alien. Their chemistry might react violently with ours. Our contamination could wipe them out. Or their chemistry could interfere with our materials, fuels, and life support systems in ways we haven't even imagined. Do we have the right, or the wisdom, to walk into an ecosystem that might run on a completely different kind of life chemistry? NASA's Dragonfly mission is already on the way. A nuclear-powered rotorcraft, a drone the size of a car, set to explore Titan's dunes and plains in the 2030s. No astronauts. No boots on the ground. Just robots. And maybe that's the point. Titan is so complex, so hostile, and so chemically rich that sending humans there too soon could be a mistake. Not just for us. For whatever Titan is cooking in its frozen laboratories. So here's the question that lingers. Is Titan the best place in the solar system to study alien chemistry? Or the worst place to risk touching with human hands? If we ever stand on those methane shores, will we be explorers, or intruders who didn't understand the danger until it was too late? Title: Titan is hiding something terrifying, and NASA knows.